Hi, my name is Sumaya. I am recording this video to introduce the Industrial Manipulator project. So the project was carried out using MATLAB. The aim of the project was to create a robot that had to pick and drop an object. So the robot had to move to 4 different locations. So let's start with the code here. So the robot had 3 links. Here we have the information for the robot elements. So each link had a value of R0, a alpha value, delta value, and a theta value. After that, the homogeneous transformation matrix for all 3 links was created, followed by the plotting for the robot, or the plotting of the robot. Next, as I mentioned before, the robot had to go to 4 different locations. So, for example, a robot had to go to the floor location to pick something, and then go to shelf 1, or shelf 2, or shelf 3. So to do this, a list dialog function. Okay, a list dialog function was used to create list selection box for the user. So the user will have these 4 selections, or these 4 options to choose from. The next step was to create the animation for the robot. And to do that, first of all, a while loop was used. So the function for this while loop was to allow the user to continue seeing the list of choices throughout the project. So to do that, to identify the 4 different locations, cases were used. So a switch case function was used to select the different locations. So here, for example, case 1, the robot had to go to the floor and pick something. Now, within these cases, a for loop was used to start the animation. Within each case, so we have 4 cases. Within each case, the theta value changes. So for example, in case number 2, theta 1 is different. So theta, it changes from the previous theta value that we have seen above. Theta value can either increase in increments or decrease. So here, for example, a plot for case 2. Now, once the plot is completed, we want the end effector coordinate to show. Again, here we have case number 3. In this case, theta 1, or angle 1, was changed. Again, a plot is carried out, and the end effector coordinate will show. And finally, case number 4, angle 2, or theta 2, is changed, and we have the end effector. Finally, there is a function. So this function is used to generate the transformation matrix. So these are the values that we use at the start of the code. So R is our length, alpha value, theta, delta value, and theta value. Okay, so let's run the code. So here we have the 4 options. So for example, we want the robot to go to the floor to pick the object. So here we can see the robot is moving, and once it stops moving, you get the end effector coordinate. Next, let's say we want, after picking the object, we want to go and put it in shelf 1. Okay, so the robot it reaches shelf 1, and we have the end coordinate, end effector coordinate for shelf 1. And let's say we want to go to shelf number 3. Let's select 3. So the robot went back to the ground, and from there it moved to position number 3 or shelf number 3. And here we have the end effector for shelf 3. Okay, that's all. Thank you very much.